Good morning, students. This is the sixth lecture in the series of hydraulic turbines. Okay, we'll see in this lecture selection of hydraulic turbine. Okay, that means we have to select a different type of the right type of turbine depending upon different condition, different types of operations. Okay, so the following point should be considered while selecting the right type of hydraulic turbines for hydroelectric power plant. Okay, now first point which should be considered while selecting the right type of hydraulic turbine is the specific speed. Okay, a high specific speed is essential where head is low and output is large. Okay, because otherwise the rotational speed will be low, which means the cost of generator will be high. Okay, now when the head is low, okay, and output is large, that means when the head is less, height is less, and the discharge is large, okay, we require high specific speed runners. Okay, now specific speed of exactly what it is, the specific speed of the runner. Okay, now if the specific speed of the turbine is less in case of low head and high discharge, then what happens is due to the low specific speed, the rotational speed will be very less. Okay, if the rotational speed is less energy will be created. That means the cost of generator and powerhouse will be very high. Okay, now on the other hand, uh, for high heads, okay, for high heads and less discharge, there is practically no need of high specific speed. Okay, we can use runners of low specific speed for high heads, because even with low specific speed, okay, due to the height difference, okay, high rotational speed can be attained. Okay, so for low heads, that means for example if you have to use Kaplan turbines, okay, then it should be high specific speed. Okay, if the head is low, we'll use Kaplan turbine because it has high specific speed, and if the head is high, okay, then we do not need high specific speeds, we can use Pelton wheel turbine. Okay, next is the efficiency. Okay, the turbine selected should be such that it gives the highest overall efficiency for various operating conditions. Okay, the turbine should be selected such that it should give the maximum efficiency. That is our main aim. Now part load operation. Okay, uh, now what is meant by part load, what is meant by part load, and what is meant by overload? Okay, now there is a fixed load, okay, that is fixed energy requirement for which an hydroelectric power plant and a turbine will work. Okay, now what is part load? Part load is the load which is less than the normal load, and overlaid load is the load which is greater than the normal load. Okay, now it is said the efficiency at part load and overload is less than it will be at the normal load. Okay, now for the sake of economy, the turbine should always run with maximum possible efficiency. That means the turbine should always run at its fixed load, okay, to get the maximum revenue, to earn the maximum amount of money. Okay, for maximum profit you can say. Okay, now when the turbine has to run at part or overload condition, if in some cases it cannot run at the fixed load and it has to run at either the part load or overload, then Francis turbine is employed. Okay, now we have seen that Francis turbine is the most common used turbine. Okay, it is used for medium head, sometimes it is used for low head, sometimes it is used for high head, so it can be used for a variety of different heads, so it is the most commonly used turbine. Okay, so it can also be used for part or overload conditions. Okay, apart from its fixed load condition, it can also be used for a overload if the load gets increased, or if the load is less, we can use Francis turbine. Now if for low heads, okay, now for low heads, instead of Francis turbine we can use Kaplan turbine. Okay, now we'll see the next. Okay, cavitation. Now we know what is cavitation. What happens is when there is sudden decrease in pressure, okay, the water starts to boil. Okay, and when the water starts to boil, okay, the bubbles are formed, and those bubbles, okay, strike the periphery of a pipe or any hydraulic machine, and they can cause wear and tear. Okay, so we have to prevent cavitation in our hydraulic turbines. Okay, now the main problem of cavitation takes place in reaction type of turbines. Okay, this problem does not occur mainly in uh, impulse turbine, it is mainly in reaction turbine. Okay, so because of cavitation we use the draft tube. Okay, now what is draft tube? It is a machine, or it is a component part of increasing area. Okay, in the beginning the area is less, and at the end the area is greater. Okay, so what happens, this low pressure water, okay, it enters this zone, and it as the pressure, as the area is increasing, the pressure also increases, and hence the effect of cavitation can be curtailed. Okay, now the critical value of cavitation factor must be obtained for every turbine. It should be obtained differently for Pelton, for Francis, for Kaplan turbine, to see that the turbine works in safe zone. Okay, such a type of cavitation factor also affects the design of turbine, especially of Kaplan turbine. Okay, the value of cavitation factor can also affect the design of turbine, specifically of Kaplan turbine. Okay, now fifth is the disposition of turbine shaft. Okay, experience show that the vertical shaft is best for large sized reaction turbine. Okay, therefore it is almost universally accepted. Okay, now large sized reaction turbine. Okay, what are reaction turbine? Francis turbine and Kaplan turbine. Okay, now for these large sized turbines, okay, we will use vertical shaft arrangement only. Okay, therefore it is the most common type of turbine shaft arrangement which we can see worldwide. Okay, now if it is a small sized reaction turbine, if it is a small size Francis turbine, okay, then we can use horizontal shaft. But if the reaction turbine is very large sized, either it be Francis or Kaplan, okay, vertical shaft should always be used. Okay, now secondly, in case of large size impulse turbines, okay, that is Pelton wheel turbine, horizontal shaft arrangement is always or is mostly used. Okay, in large size impulse turbine, that is Pelton wheel turbine, horizontal shaft arrangement is used, and in large size reaction turbine, vertical shaft arrangement is used. You have to know the difference. Okay, so and the last point over which we will select different type of turbine for different condition is the head. Okay, now if the head available is very high, okay, if the head available is very high, that is greater than 350 meters, okay, Pelton turbine will be used. We know that Pelton turbine is an impulse type of turbine, and impulse turbine are used for high heads and low discharge. Hmm. And in the cases of height above 350 meter, only Pelton turbine is used. There is practically no other choice except in very special cases. Okay, so this is for very high head greater than 350 meter. Now second, high heads, that is 150 to 350 meters. Okay, in this range either Pelton or Francis turbine may be employed. Francis turbine, you know, it is used for medium heads. It can also be sometime used for high heads. Okay, now if the specific speed, okay, if the specific speed of the runner is less, then Pelton turbine is used for high heads, and if the specific speed is higher, then Francis turbine is more compact and economical than the Pelton turbine. Okay. Third is the medium heads. Medium head, that is between 60 meter to 150 meter. If the difference between the reservoir and the turbine, okay, is 60 to 150 meter difference in height, then Francis turbine is usually or always employed in the range. Now whether we use high or low specific speed unit, okay, we will only use Francis turbine for medium heads. Okay. Now for low heads, that is below 60 meters, between 30 and 60 meter heads, both Francis and Kaplan turbine can be used. Okay, so we can see Francis turbine, it can be used for high heads, for medium heads, and also for low heads. Okay, now for lower heads, much lower head, Kaplan turbines are used. It is generally employed for heads under 30 meter, and propeller turbine are commonly used for heads up to 15 meter. We do not have this in the syllabus. We have only Kaplan turbine. Kaplan turbine is used for heads below 30 meters. Okay. So these were the 6 points on the basis of which we will select the suitable turbine for suitable conditions. Okay. Thank you. In the next lecture, which will be the last lecture in the series of hydraulic turbine, you will see the function and description of a draft tube. Thank you.